A model engineering comedy of errors, part 1. This is a perfect example of what happens when you get the job wrong right from the start. Some of these mistakes are made on purpose, but most of them are due to my utter incompetence. And the incompetence starts right at the beginning. I was looking for a piece of cast iron and I found this, which looks very much like cast iron. And at some time in the past I had turned part of it and it looked pretty good. I should have known right at the beginning that this was not going to work out, because I do not remember ever buying a piece of cast iron as long as this. The original intention was to make a new pair of individually adjustable eccentric sheaves for the triple expansion engine that I'm working on. Even though this is a very long piece of metal, it's the correct diameter for the job. What I'm doing here is cutting it to a manageable length to fit in the chuck of my Boxford lathe. And to do this I'm using my trusty bandsaw that's not very good quality, but it doesn't know that, so it works very well. This piece of bar actually cut very quickly. Once I picked up the cut part of the bar from the floor, I fitted it in the chuck of my Boxford lathe. When I watched the turning process, it occurred to me that this wasn't cast iron after all. And while on the subject of turning, it was really difficult. I could not get a smooth finish, irrespective of how fast I made it rotate and how slowly or fast I moved the cutting tool across the front of it. At this stage I should have halted the proceedings and gone back to bed. Today is not going to be a good day, and this is only the beginning. I was quite puzzled why this piece of metal that looked like a piece of cast iron was not turning anything like cast iron. I think this is a piece of steel. This piece of steel is like no other piece of steel that I've come across for many years. Normally I buy free cutting mild steel, which machines beautifully, or stainless steel, which machines equally beautifully. Here's the opening clip again, and as you can see, it looks like a piece of cast iron that's been partly turned. After starting the machining operation in my small Boxford lathe, I realised this wasn't going to work. Instead, I changed lathes. I fitted it into the 4-jaw self-centering chuck in my Smart & Brown lathe, and the turning was a good bit better. Once again, the tool is sharp, but the way the swarf is coming off this, there's no way in the world is this cast iron. It is steel, and it's a very hard piece of steel. This is the best finish I could get on the front, and I'm using the power cross feed. I know, I'll try again. Still using the power cross feed, I slowed down the feed, so now it's running quite fast, but the feed is incredibly slow, so theoretically I should get a good finish. Why am I continuing with this fiasco? Well, to be honest, I've been out of the main workshop for a couple of weeks because of the surgery that I had, so this was the first time I'd been in there for a while. I'm not using that as an excuse, but really, when I think about it, I wasn't really in the mood for machining on this particular day. Here I am, still on the Smart & Brown with the power cross feed, and I'm using a different tool. This tool normally cuts very well indeed, but it's not doing. I increased the speed of the feed as it got towards the middle, but it made no difference. A viewer was asking me about different types of metals, and I really do not know much about different types of metals. All I can say is this one is a horrible piece of metal. I don't know what it is, and I don't want to know what it is. I know, I'll try some metalworking spray. This is really good stuff. This should give me the finish that I want. And to prevent any viewers accidentally slipping into a coma, this part of the video is running at 8 times normal speed. That is 800%. With the metal cutting spray, I did get a marginally better finish, but it's far from perfect. For the moment, which was not a good idea, I thought I would continue the job using this piece of metal. What I'm currently doing is making a very small centre point in the middle of the work, with a centre drill in the tailstock chuck. Okay, so the finish still isn't very good, I am aware of this, but maybe I can clean it up later with some emery cloth. Time to look at the drawing. I've blurred it out for copyright reasons. and on the drawing it tells me that the throw of the eccentric is 7/32 of an inch. This clip shows the very fine centre mark in the middle of the work, and now I need to paint the end of this with some marking out blue so I can see what I'm doing. Using my digital caliper set to 7/32 of an inch, I scribed a line around the hole in the centre. Why did the line wander off? Well, once again I made a mistake, the caliper slipped. What's the saying? Measure twice, cut once. And here I'm measuring twice, this time using a steel rule from the centre to the edge of the mark. And yes, it is still 7/32 of an inch. Now I need to carefully use a centre punch to make a mark on the ring around the centre mark. I made some fine adjustments to the position of the centre punch and repeated the process until I got a very accurate centre punch mark on the line. Once again, now it's over to my Boxford lathe and I need to remove the 3-jaw chuck to fit the 4-jaw chuck. The trouble is, the 3-jaw chuck is very firmly attached to the thread on the spindle, and it is very important not to put side pressure on the chuck key, because this can actually damage the chuck and possibly the chuck key. The question is, how do you remove a 3-jaw chuck from a Boxford lathe when it's very tight? This is how I normally do it. I use a piece of bar in between the jaws of the chuck. Then I press the button on the side of the headstock to lock the spindle. Then I use the leverage of the piece of bar, which is quite long, to release the chuck from the spindle. An obvious word of caution, do not use this method if you are using a D14 type chuck which has pins that go into holes on the spindle. This method is only suitable for releasing a chuck from a threaded spindle. It's very important to always keep a threaded spindle very clean indeed. Any particles of metal on the thread will make fitting the next chuck inaccurate. It's not really good enough to just use the random paintbrush that you have in the chip tray to clean the threads. I use some of this stuff. Occasionally I use WD-40, but I've run out of that. This, as it says on the can, is Service-All Super 10. It's an electrical cleaner. And after it's done the cleaning, it leaves behind a very small amount of silicone grease lubricant. I apply it using a clean toothbrush. That's it for this one. Stay safe, stay healthy. Thanks for watching, and I hope you found it useful. Please take the time to visit my Mainsteam Models website and click on the section of the website that says Video Playlists. And by doing that, you can find other videos that you may like to watch. And by using the playlists, you can actually watch the videos back to back.